Birds of prey, such as falcons, hawks and eagles, have some of the best eyesight in the entire animal kingdom. With vision far superior to that of any human, some species can spot a moving target from over 2 miles away. Many, such as the Harris hawk for example, can spot tiny prey items in very thick vegetation, a very valuable ability indeed when hunting in enclosed habitats. Amongst a variety of different anatomical features, the main reason why birds of prey have such superior vision to most other animals is simply because they have the most enormous eyes in relation to their skull. The bigger the eye, the more light it can gather, and also the more room there is for light detecting cells within, therefore enhancing visual acuity and resolution. With this goshawk, for example, his large orange eyes already seem large enough, but when you see the skull of a goshawk, you can clearly see by the size of the eye sockets themselves how much room the eyes occupy within the skull itself. Having such gigantic eyes, however, can produce problems. In these birds, for example, their eyes are so gigantic they can barely move in their sockets, which means that they can't look around the way humans do. To compensate for this, all birds of prey and owls, along with virtually all other bird species, have a very long flexible neck compared to most mammals. A typical bird of prey or owl has double the neck vertebrae compared to that of most mammals. In a human, for example, we have 7 neck vertebrae, whereas a hawk has 14. What is more, these neck vertebrae are quite small in size, which only adds to the mobility of the neck, compared to the rest of the spine, where the vertebrae is much thicker and attaches more closely, making the spine more stiff and rigid. This long and very flexible neck enables birds to reach virtually any part of their bodies, enabling them to preen in the way they do, using their beaks to comb through their plumage, which are so vital in maintaining flight. This also enables birds of prey to scan over a wide area of terrain with their incredible vision, increasing their ability to spot a stationary or moving target in any direction. However, when it comes down to maintaining visual periphery as well as balance, this is where things get weirdly interesting. When a bird has visually locked onto its target, it is able to maintain its head in a stable position while its body moves independently, which is known as gaze stabilization. Birds such as this Harris hawk are able to do this while perched or in flight, able to keep completely focused on a located target. This ability is essential not just for birds of prey in terms of hunting, but also all birds that fly, for it enables them to process such a wide range of visual information and thus move their heads and bodies accordingly when flying. All birds that fly seem to have an innate sense of what is up and what is down, and can move their heads independently of their body while their body rotates when moving around in the air, for example, which is in stark contrast to most mammals, where a muscle attaches the skull to the spine, meaning wherever the body goes, the head follows. A combination of unique muscle attachments in the neck, combined with the neck's unusual flexibility as we've previously discussed, is the main reason how these birds can move their skull independent of their bodies so effectively. In diurnal birds of prey, this phenomenon is often noticed most heavily when observing hovering kestrels, for example, which rely on their keen vision to spot the movement of small mammals and reptiles on the ground while they hover stationary in the air. These small falcons often hover by flying into a headwind and make micro-adjustments with their wings and tail to maintain a steady position, so maintaining eye contact on a moving target while they're doing this is essential. The ability to move the head independently of the body is vital to the hunting success of various raptors, especially peregrines for example, which make the fastest maneuvers of any bird. When plummeting downwards in a stoop that can reach over 200 miles per hour, maintaining a clear view of your prey while making various minute adjustments to your body and wings while making this descent is essential. This is why peregrines have the fastest visual processing of any bird of prey, with a recent scientific study showing that they can register 130 Hz or blinks per second in a high light intensity environment compared to Harris hawks at 77 Hz. Interestingly, the peregrine's vision also seems quite unique in that it seems that the sharpest point of their vision is not straight ahead like it is in us, but angled off at 45 degrees. This visual feature may explain that while the peregrine is doing its long stoop downwards, it often plummets in a corkscrew type fashion, twisting and turning its body as it adjusts to its speed. All while this is going on, its head remains completely straight, while its target is locked in the sweet spot of its vision, so to speak, which means it can make the fastest route to its target possible. If the peregrine was to fly straight towards its target with its head turned aside, it would create drag and therefore reduce speed. With such effective gaze stabilization, the peregrine can remain visually locked on its target and move its body completely independently, adjusting itself to maintain the maximum speed possible to capture its prey with such tremendous speed as they do. Gaze stabilization is also a feature seen in owls, albeit with slightly different features to some diurnal birds of prey. This is because although owls certainly rely on their vision to locate prey when they can, they also have especially acute hearing. Take for example the barn owl. It, along with other owl species, has a row of stiff feathers on the sides of its face forming what is known as a facial disc, which works almost like a feathered satellite dish. This feature helps channel sound to the owl's ears, which are located beneath the feathers and are extremely sensitive, estimated in some species to be up to 10 times more so than a human's, which enables them to locate small rodent prey, for example, in thick undergrowth. Owls are well recognised in engaging in a comical behaviour where they turn their heads curiously to the side and bob their heads up and down when observing something. It is believed that the reason for this is because owls are largely long-sighted, as their vision is well designed for locating prey at a distance and also in the dark, so when they do this, they are basically maximising their depth perception, helping them to visually focus on something either up close or from a slight distance. However, they also do this when scanning for prey using their sensitive hearing, gathering sound waves with their facial disc with which their ears can detect. Overall, gaze stabilization in birds of prey and owls is a highly useful and fascinating ability used to locate prey, yet another feature that makes them the expert predators they are.